All right, greetings one and all, and welcome to this video. In this video, I'll be explaining how to balance chemical equations. So we'll be looking at balancing chemical equations. So let's move forward. So let's say we have this equation. So the equation is this chemical equation. It is C3. Okay, so we have carbon, we have H8, so that's hydrogen. And so we have C3H8, so we have carbon and hydrogen. And let's say we have oxygen as well. So we have O2. And let's say we have carbon dioxide. And that's what? And then we're going to add water. Okay. So we have this equation. All right. This entity plus this entity produces these two entities. And it's important to note that this side, right? This side we call this side the reactants. Okay. Reactants. Okay. And the next side we call the products. Okay, the next side we call the products. Okay, so we have the reactants on one side and the products on one side. And what that basically means is that the reactants are those entities that's going to combine together. And when they combine together, they're going to give us the products. So the reactants give us the products. Okay, so this entity, right, which is a combination of carbon and hydrogen, plus oxygen is going to give us carbon dioxide and water. And so where we have the reactants on one side and the products on one side. Now the question is, right, how do you know if an equation is balanced or not? Okay, so before we actually go ahead and balance it, what if it's balanced already? Okay, so how do you know if a chemical equation is balanced already? Okay, now in order for a chemical equation to be balanced, right, every one of those elements must be they must have the same number. All right, so what I mean is if we look at carbon, right, if we look at carbon, let's say for example look at carbon on the reactant side. So carbon on the reactant side, we are going to just denote that as C. And notice that for carbon we have 3, right? So for carbon we have 3 on the reactant side. Okay, but when we go to the product side, how much carbon do we have? Well, on the product side, right? How much carbon do we have? Again, on the product side, how much carbon do we have? Well, here we had 3. We have 3 for carbon, but here notice that we don't have no number, and when you don't have no number, that means you're dealing with 1. Okay, so here we only have 1 carbon. Okay, so this is going to be 1 for carbon. So we can clearly see that there's an imbalance here, because here for on the reactant side we have 3, but for the product side we have 1 for carbon, and so there's an imbalance. So we know that this equation is not balanced. Moving further, for hydrogen on the reactant side we have 8, and we know that because notice we have 8 for hydrogen, and for hydrogen on the product side we have, notice the symbol in front of hydrogen. Notice the 2 in front of the H. That means that we have 2 for hydrogen. So this is going to be 2 for hydrogen. So on the reactant side, we have 8. And on the product side, we have 2. So that means that we have an imbalance here. Okay. And then finally, let's look at oxygen. Okay. On the reactant side, we have 2 for oxygen. And on the product side, we have, we gotta be careful for this one, because here we have 2, okay, but here again we have another one, so that's 2 plus 1, which is going to give us 3. Okay, so this tells us, right, that clearly the chemical equation is unbalanced. Right, it's unbalanced. Now it's unbalanced because if we look at our reactants, the reactants don't have the same number as the products. Now, in order for us to make it balanced, each one of the reactants must have the same number as the products. So if this is 3 for carbon, this must also be 3 for carbon. If this is 8 for hydrogen, this must also be 8 for hydrogen. If this is 2 for oxygen, this must also be 2. So in order for an equation, a chemical equation, to be balanced, for each one of the elements that we have, they must have the same number, okay? Now, if only one of those elements don't have the same number, then the equation, the chemical equation, is unbalanced. Okay, so that's how you could identify if a chemical equation is balanced or not. Okay, so we are dealing with an unbalanced chemical equation. And so let us balance it. Okay, so let's balance it. Now we are going to keep the same thing, the same format, reactants and products. Okay, we're going to keep the same format, keep the same table. And then now we're going to work to make sure that it is balanced. Okay, so notice that for hydrogen on this side, notice that for carbon on this side, we have 3. And so we're going to put 3 here. But remember that because there are 3 for carbon on the reactants, we want 3 for carbon on the products. So I am going to put 3, okay, let's use purple. I'm going to put 3 in front of our carbon. And so now we have 3 for carbon here. All right, so there are 3 carbons here. So, and there are 3 carbons on this side. So 3 carbons on this side and 3 carbons on this side as well. So this is going to be 3. So that is good. Okay. Now, the next element that we're going to move to is hydrogen. Notice that we have 8 for hydrogen here. And so let's put that. But notice that for hydrogen on this side, we only have 2. So we need to fix that. What times 2 is going to give us 8? Because remember, we need to have 8. Notice that here we have 8, so we need to have 8 as well. So what times 2 is going to give us 8? Well, that's 4, so we're going to put 4 here. Because 4 times 2 is definitely 8. So we're good so far. We have 3 carbon for this side. So we have, for carbon on this side we have 3. For carbon on this side we have 3. For hydrogen on this side we have 8. For hydrogen on this side we have 8. And so we're almost balanced. The only thing we have to balance now is the oxygens. Okay. Now we have to be very careful for the oxygens, because notice here this is saying 3. The number in front of this also applies for the oxygen as well. So this 3 not only applies for the carbon but also applies for the oxygen. So we're saying 3 times 2. 3 times 2. 3 times 2 is definitely 6. Okay, so that's 6. Plus, we still have some more oxygen. We have this oxygen here. When it by itself and it don't have no number, that we know that it only counts for 1. So this is 4 times 1, because we don't have no superscript. We don't have no subscript underneath it. So we know that it's only 1. So 4 times 1 is still 4. Okay. So that means on this side, on the product side, we have 10. We have 10 oxygen. Okay. On the product side, the number for oxygen is 10. Now on the reactant side, we need to make sure that we also have 10. Okay. And so the question is, what times 2 is going to give us 10? Again, what times 2 is going to give us 10? Well, the answer is 5. And so notice that for our oxygen on the reactant side, we have 5 times 2. And 5 times 2 is definitely 10. Okay? 5 times 2 is 10. And so let's look at it. Notice that for the reactants, for carbon, we have 3. And for the products, for carbon, we have 3. For the reactants, for hydrogen, we have 8. For the products, we have 8. For oxygen on the reactant side, we have 10. And for oxygen on the product side, we have 10. And so therefore, we can say that this equation is chemically balanced, right? So we have a balanced chemical equation now. Okay. So this equation right now is currently balanced, and we made it balanced by putting in these numbers to make sure things balance off. That whatever we have for the reactants, the numbers that we have for the reactants, right, it matches the numbers that we have for our products. So this equation is balanced. Okay, let's do another example. This one is going to be a little bit more involved, so you have to be paying attention for this one. This one is not as straightforward as this first one, but hopefully it makes sense. So please pay keen attention to this one. And I encourage you, as I do it, before I do it, you could pause the video, try to do it on your own, okay? And then after you do it on your own, then you could play the video and see what I have done. So we have carbon, we have hydrogen, plus oxygen, and this is going to give us carbon dioxide and water. Okay, so the question is this equation balanced? Okay, pause the video, attempt it on your own, try to balance it. First, ask yourself, is it balanced? One, and then two, if it's not balanced, how do we balance it out? So is it balanced? Well, notice that for carbon on this side we have 4, but for carbon on this side we only have 1. So that's an imbalance there already. For carbon here, for hydrogen we have 10, and for hydrogen here we only have 2, so that's another imbalance. Okay. For oxygen here we have 2, and for oxygen here we have 2 plus 1, that's 3. So that's an imbalance there. And so we have to balance this, because this equation as it stands is currently unbalanced. Okay, it's not balanced. And so that means that we have to balance it out. Okay, so let's do the same thing we have done. We're going to make a table containing 2 columns. So on one side we have the reactants. On one side we have the reactants, and on the other side we have the products. Okay. All right. So notice that for carbon, we're going to start off with carbon. For carbon, we have 4 on this side, and so let's jot that down. But for carbon on this side, we only have, on the product side, we only have 1. So that means that we have to put a 4 in front of this carbon, in front of the C. So let's put the 4 there. So now we have 4 carbon. Okay, great. Next, we have hydrogen. So let's deal with hydrogen. Okay, so for hydrogen on the reactant side, we have 10. Okay, and for hydrogen on the product side, we only have 2. And so what times 2 is going to give us 10? Because we're trying to make it to be 10. What times 2 is going to give us 10? That's definitely 5. So 5 times 2 is going to give us 10. So we are good on right here. So that's 10. All right, so now the oxygens. And this is where it becomes involved and you have to pay attention. For the oxygen, notice that we have 2 oxygen here, okay? And for this side, notice carefully that on this side, we have 4 times 2, 4 times 2, 4 times 2 is going to give us 8. So we have 8 plus, notice that this is 5 times 1, because once it's by itself with no subscript, we consider it to be just we consider it just to count for 1. So it's going to be 5 times 1, which is simply 5. And so this is going to be equal to 8 plus 5. Well, 8 plus 5 is definitely 13, because 8, 9, 10, 11, 12, 13. So notice that on our product side, we have 13, but on our reactant side, we only have 2. Okay, so the question is, what can we multiply by 2 to give us 13? Interesting question, right? What can we multiply by 2 to give us 13? Now we could put that in a form of equation. So we can say if we have 2 multiplied by something, we don't know what it is. 2 multiplied by something gives us 13. What is that something? And since we don't know what that something is, let's call that something, let's use a letter to represent that. So it's going to be, let's say we use P. So we're going to say 2 times P equals 13. Now we try to solve for P, so it's going to be 2P equals 13. Next, we divide both sides by 2. And so it's telling us that P equals 13 over 2. Okay, so P equals 13 over 2. So what times 2 is going to give us 13? Well, the answer is 13 over 2. And we could express this as a decimal. Okay, so what is 13 divided by 2? So let's do that. So this is going to be 2 goes into itself. Sorry, 2 goes into 13. How much times? Well, 6. And 2 times 6 is 12. 3 minus 2 is 1. Put the decimal point. So let's put the decimal point carefully. So 6.5, sorry, 6. So we have 6 point, and then we could have the authority to put a 0 here because we have the decimal point on top. What times 2 gives us 10? The answer is 5. So that is 6.5. So P is 6.5. And so that's very important. So what that means is if we say 2 multiplied by 6.5, that's going to give us 13. Okay, so 2 multiplied by 6.5 going to give us 13. And we can always verify that our answer is correct. Let's use a calculator. Give me one moment. And let's use a calculator. So we want to use a calculator. So this is going to be, so let's say scientific calculator. And so what we want to do is we multiply 2 times 6.5. And we see that 2 times 6.5 is 13. Okay. All right, so let's go back to our setup. So that means that the number that we need to place in front of the oxygen is 6.5. So you could put 6.5, or you could put, instead of putting 6.5, you could also put its fractional form. You could also put 13 over 2. Okay, either of them works. Okay, so but let's go with 6.5. So let's use 6.5. So this is 6.5. So let's see if everything is balanced. Notice that for carbon we have 4, and for carbon here on the product side we have 4. For hydrogen we have 10, and for hydrogen here 5 times 2 is 10, so we have 10. For oxygen on the reactant side we have 6.5 times 2, and that gives us 13. And for oxygen on the product side we have 4 times 2, which is 8, plus 5 plus 5 times 1, which is 5, and 8 plus 5 is 13. So here we have 2, so here we have 4, 4, 10, 10, and 13, 13. And so that means that this equation, this chemical equation, is balanced. This chemical equation is balanced, okay? But we do not like to express, or we would rather express our chemical equation in such a way so that we do not have any decimals, okay? So we want to express our chemical equation in such a way so that we don't have any decimals. And here we have a decimal. So what we're going to do, we're going to alter this equation so that, we don't have no decimal, okay? We don't have a decimal here. And remember, and so the question is, what number we could use to multiply this equation, this entire equation, so that we could get rid of that decimal number, okay? Can I erase? Okay, these are not erasing, so we have to take it on to the next slide. So again, if we remember, we have, sorry, let's simply take this, make a duplicate, okay? So take this, make a duplicate, and let me copy, this. All right, so this is what we have. This is the equation that we have. It's technically balanced, but we don't want any decimals, okay? So what can we do to get rid of that 6.5? Well, in order to get rid of that 6.5, we're going to multiply the entire equation by 2. Sorry. We're going to multiply the entire equation by 2. And the reason why we're going to multiply the entire equation by 2, because notice that 6.5, it really is 13 over 2. So if we multiply the 2 by the 13 over 2, these 2 would cancel, leaving us with 13. So let me emphasize that again. Remember, 6.5 really is simply 13 over 2. And so what times 13 over 2 is going to get rid of the denominator? Because remember, we don't want to have any decimals or fraction. We just want a straight up whole number. So how can we multiply the 13? What can we multiply by 13 over 2 to give us a whole number? Well, the answer is 2. You can multiply by 2. And so if we do that, these 2 would cancel out, leaving us with 13. Okay, so let's do that. So, and we only doing that because we want to have only whole numbers for our chemical equation. And so we are left with, remember, we are multiplying everything, every term by 2. So it's going to be 2C4H10 plus 2, so you multiply 2 by that, and then 2 by this. 2 times 6.5 is 13, so that's 13O2. Now 2 times 4 is 8, it's 8CO2. And then 2 times 5 is 10H2O. And so now let's see if this equation is actually balanced. Okay. Remember, we have the reactants, and then we have the products. Okay, so the reactants, if we're on the reactants, carbon is going to be, notice that carbon is, this is 2 times 4. So 2 times 4 is 8. So carbon is going to be 8. And let's go on the other side and let's look at carbon. Notice that The number in front of carbon is 8, so carbon is 8 as well. Next up, we have H10. So that means that this 2 also is multiplied by the 10 as well. So 2 times 10 is 20. So that's H is going to be 20. And so let's look at the other side. Notice that for hydrogen, we have 10 times 2. 10 times 2 is 20. So hydrogen is going to be 20. And notice that for this one, we have oxygen. And oxygen, we have 13 times 2. 13 times 2. And 13 times 2 is for oxygen. Oxygen, we have 13 times 2. And 13 times 2 is 26. And if we go on oxygen on this side, we have 8 times 2, because it's 8 out front. It also goes for this. So we have 8 times 2. 8 times 2 is 16. Plus, we have 10 times 1. And so 10 times 1 is 10. And 16 plus 10 is 26. And so that means that this equation here is balanced. Why? Because we have 8 carbon for both. We have 20 hydrogen for both. And we have 26 oxygen for both. Okay, so therefore this equation here is balanced. Okay, so hopefully this helps you moving forward with balancing certain chemical equations. I am going to allow you to take opportunity to try this one on your own. So try this one on your own. Al plus HCl, and that's going to produce AlCl3 plus H2. So try to balance that out. First, determine if it's balanced, and then after you determine if it's balanced, then go forth and balance it out. Okay, so hopefully, with the information that I gave you, you should be able to hopefully answer this question. So that's it for this video. Hopefully, this video helps, and I'll see you in another video.